Welcome everyone. Today we are diving into the world of Docker, a powerful tool for containerization. In this video, we will see what all components are there for Docker and what all basic commands we can execute for installing Docker and pulling the images from the Docker Hub. But before we jump into hands-on part, let's understand the key components of Docker. Docker consists of three main components: the daemon, the client, and the Docker socket. Daemon. So this is the first component. The daemon is like the heart of a Docker. It manages the creation, running, and life cycle of the containers. On the other hand, the client is our interface to Docker. It's where we execute Docker commands, typically through the command line interface. Third and most important one is the Docker socket. Now here's where the magic happens. The Docker socket facilitates communication between the client and the daemon. It ensures that commands from the client are passed to the daemon for the container creation and management. So this was the overview of Docker components, and it's pretty much that you need to understand the architecture of a Docker. Now that we understand Docker's component, let's get our hands dirty with some practical examples. So, firstly, we will need a virtual machine. Let's call it as a VM1. I named it as a VM1. I already spent it over Azure portal, and I have already connected this VM through PowerShell. Now, what we will try we will try to clone a Git project so that we can do a hands-on on containerization, basically to containerize our application in a Docker so that anyone can use this application or can run this application on their machine irrespective of the environment. So for that, I have already created a demo project. We can clone this project in the VM1. So let me clone that. Git clone and the URL. So we see it cloned our project. So let's do the ls command and we see we have a demo project. So let's clear the output and let's get into the demo project folder. Okay, so we see there are files already present in the repository. It's the same files over here. So for doing hands-on with Docker, what we will do is we will try to package our application, basically build our application. So for that, as this demo project is a Java project, so we will need a JDK and Maven as a prerequisite. So let me see if we have Maven already in this machine. So Maven version. Okay, Maven command is not found. Let me try Vn. Okay, it's not there. So this confirms that Maven package is not there. So let me install that. Sudo apt install Maven y. Okay, so it's showing some error unable to locate package Maven. So let's first try updating all the package. Sudo apt update. So this command will update all the repositories that are present in on this Ubuntu machine. So hopefully after updating all the packages, we will be able to install Maven. So now let's try to install Maven again. So we see now it have resolved the issue and we are able to install Maven. So let's wait till it gets completed 100%. The good thing about installing Maven is that it will install JDK as well with Maven. So we don't have to install JDK or Java separately. Okay, so we see that installation is completed. Let me check the Java version. Okay, we see that JDK 11 is now installed. Let me check Maven version as well. So we see that Maven 3.6.3 is installed. So now as we have JDK and Maven installed, we can start packaging our application. So for packaging our application, we can run the command mvn package. So we will wait for this command to complete. With this command, what we are accomplishing is that we are trying to package our source code along with all the dependencies. So let's see, there is some error while compiling the code. Let me check that. We can see that build is failed because of this compiling error, release version 17 not supported. So let's try to check. So generally this configuration where we specify the versions is present in the pom.xml file. So let's check that one. Get pom.xml. Okay, so if we go over this XML file, we see that Java version is set to 17. Although, if we check our Java version, it's Java JDK 11. So due to this mismatch, it is causing the issue. So what we can do is let's try to edit this pom.xml. So vi.xml. Let's try changing this to Java 11 instead of Java 17. Okay, let me just verify if it has changed or not. Okay, now it's 11. So let's again try to package our application. Let's see if it gets completed. Okay, so still we are seeing some errors. Let's check that. Okay, so it seems that there are some compatibility issues between the versions of Spring Boot dependencies and Java version that I'm using. So basically, these error messages indicate that the classes in Spring Boot jars have been compiled with higher version of Java, which is Java 17, and what I am using is Java 11. So what I can do, let me try upgrading Java present on this machine. And while installing Java, it seems Java 17 is not present in system repository. So what we can do is that we can add a new repository for this Java 17. Let me add that sudo add repository ppa. Okay, so basically PPA is personal package archive, and we are using for this purpose for installing for adding Java 17. So we see user or team does not exist. Okay, so for this, my mistake, there should be no colon in this. Adopt OpenJDK. Seems we are still facing an issue. So let's try installing directly Java 17 from Ubuntu repositories. So what we can do is let me first quickly update the packages and then I will install OpenJDK 17. Okay, let's wait to for its finish. Okay, so now we can see we have a OpenJDK 17. So one more thing we need to check again is pom.xml file. We made changes in that file, so we need to revert it back. So it was version was 17 instead of 11. I will switch it back. Let me just check, verify it again. Okay, and second thing that we need to make changes is the target folder, because every time when we run mvn package command, it will create a target folder. So right now we don't need, as it was not successful. So let me remove that. Okay, so now it should not give any errors. So let me try to run that again. mvn package. Okay, so now we see the compilation is successful, and now we can see that after a successful build we have a target folder and we have a byproduct.jar file. Basically now we have package in this .jar file, we have package our source code with all the dependencies present in it. When we package with Docker later, it will include not only the jar file but also the environment configuration. Now let's clear the output and start working with Docker. Let's install Docker using a command sudo apt installed docker.io. We hit yes. Let's wait for its completion. Okay, we see now Docker has been installed. To test if it's successfully installed, let's try pulling one of the sample images from Docker Hub. So with the help of Docker pull command, we can try pulling the sample image. So let's pull hello world. Okay, so as we see that got permission denied with trying to connect to the Docker daemon socket. So this was expected because generally we can run Docker command as a root user. So there are two options: either we go into the root user or add our current user to the Docker group. So for ease, let's get a user root user access. Now again try to run docker pull command. Okay, now we see that it pulled the Docker hello world image. Let's try to check Docker image. Okay, so we see that hello world is now pulled and we have that on our machine. This was the sample image. Generally, we work with the Alpine images, which is a Linux-based image and it's very small in size. So we tend to work with those images. So let's try to pull that as well. Sudo pull Alpine. So this is the base image, Alpine image that we can pull. But suppose if we want a specific version of Alpine image, suppose we want 3.16.7 version, so we can specify version in this manner, colon and the version name 3.16.7. Okay, sudo pull command not found. So my bad, it should be sudo docker pull. Okay, so again, let's check the images. Docker images. So we see that now we have pulled the Alpine image as well. Basically, our goal with Docker is to ensure that anyone can run our application regardless of their environment. So right now we have discussed the components of the Docker and we know how to install the Docker and how we can pull the basic image. So we have taken our first step into the world of containerization. So in next video, we will discuss how we can share package image with the help of a Docker file and how we can pass on this image to other colleagues, other people so that they can run without any configuration changes on their machine. Thanks everyone for watching this tutorial. Don't forget to like, share and subscribe for future updates. Happy containerizing.